Okay, it's about 2 o'clock. Today we're going to talk about societal energy use. It's our first. Now we're moving away from thermodynamics to broad scale societal energy use. One, sorry, there's a distraction from my children. We're going to be talking about societal energy use, but first I want to do a few class announcements, so I'll get into that now. I posted them to Canvas, but I just want to reiterate them here. So let me share my web browser. Go back to here, home, announcements. So two things. The Federal CARES Act is available to students suffering financial hardship due to COVID-19 or other reasons. And a bunch more funding just became available. So if you are in need of a computer or something like that to facilitate your education here at Western, please click this link in the announcement section. And there's an application for student emergency funds established by the Western Foundation that funnels these federal dollars to your ability to learn better and more effectively. So take advantage of that. I don't know when the application. Okay, so the application is due Monday, October 26th. So you don't have a lot of time. So if this is something that you need to take advantage of, do so. The money's there for you. Don't let it go to waste. So that's announcement number one. Have a look at that. And then announcement number two, I was going to release homework 3 today, and it was going to be due Monday. And then I was going to launch the midterm Monday. But I thought that, first off, there wasn't going to be enough time to do a study session like I've done for the first 2 homeworks. And secondly, it just seemed like too crammed. And so I'm going to take some of that material and put it into the midterm. I'm writing the midterm right now. I'm not making the midterm bigger or anything like that. I'm not just piling it on to the midterm. I'm just gonna use some of that material for the midterm. So what, in terms of societal energy use, the things that will be on the midterm, I want you to watch a short documentary film on Mauritania, an African nation in the Western Sahara, and then get a little familiar with these 2 societal energy use databases. There's one from the CIA and there's one from the Energy Information Administration, and they track things like primary energy use for all the different nations. I mean, it's a matter of national security, right? If all of a sudden a country loses its energy source, it's going to become geopolitically destabilized, likely fall into civil war that can then spread elsewhere. You can look at the Arab Spring in the last decade, or Venezuela presently, to think about how societal energy use or lack thereof can lead to things like war. And so that's why, the CIA is interested in these things. The EIA, the Energy Information Administration, is located in Washington, D.C. on the Smithsonian Mall, and they track energy use primarily in America, but also all the other nations too, as well as like carbon emissions and things like that. So I'll have you pull some data from these 2 resources on the midterm. So if you want to have a look at how those servers work now, you're welcome to, but they're pretty easy. So those are the 2 announcements. CARES Act, take advantage of that. And then no homework 3, and a little preview of at least 1/3 of some of the material that will be on the midterm right there. Looks like something happened in chat. Thank you. I have tons of things to do. Could you still post the homework? Is it a study type thing for those kinds of problems? No, because I'm going to poach from the homework for the midterm. But I'll drop hints in the next 2 days of what sort of things will be covered. But certainly these 2 websites, we'll look at them. I can show you what CIA World Factbook looks like, for example. So this is it here. Do I know how to use it? I think, yeah, regional and world maps. No, that's not it. Okay, maybe I need to have a look at the CIA World Factbook before I jump into it. About appendices. Where's world travel facts, regional maps, guide to country comparisons. Okay, I'm gonna have a look at this before I make you navigate it. And it's different now. Everything's changing. Here is the one I am familiar with. This is the EIA, Energy Information Administration. And so you can click a nation like Mauritania and get some quick data on like petroleum production, total energy production, energy consumption per capita. So then you have information about like, you know, the population, stuff like that. So here's population. So they have 4,529 people in thousand. So you multiply by 1,000, they have 4.5 million people. These sorts of information is available for all the different nations. Okay, let's jump into it. What information would you like us to emphasize in these websites? Population, wealth, that's gross domestic product, which I'll discuss today. Primary energy use, and population. So we can think about, you know, how much money people have, how many people they have, and how does that relate to how much energy they use. We'll talk about all this today. So today we're gonna do societal energy use and something called the Kaya identity. But before I do that, there's a lot of preamble today. I want to go over let me make sure that I'm sharing the right one. I want to go over the lecture that I abandoned in place of a study session the other day, and that was a short history of world energy use. We don't have time to do it, but I posted it to Canvas. I find this fascinating. Take home points is we live in incredibly bizarre, interesting, fascinating times. I recall from day one that we use 140 times more energy outside of our body than we consume. And this all happened in the last 300 years. We are way off our evolutionary ability to understand how much energy we use on a personal basis. Our senses didn't evolve for this amount of energy use. And it's crazy. And it's leading to big environmental problems. And so this is something really fascinating to study over the course of human history. I want to just show this one last chart. It's historical energy growth over the last 200 years. And we were using hardly anything at all prior to the Industrial Revolution. It was basically, self-sustenance, where we just grow enough crops to heat our homes and feed our animals and grow our food. And then until the early 1900s, we were just using wood and coal. It was all wood back then. And then with the development of coal energy in England, it was nearly 100% coal use until post World War I, and then oil became a more dominant energy supply. But coal still was the primary energy supply until after World War II, when oil became the prominent energy carrier for society. And it still is today. We're still in the oil age. And right now we're transitioning from oil to natural gas, unfortunately, despite renewables now being cheaper than natural gas. And despite the fact that natural gas causes just as much global warming as coal because of methane leakage, something we'll talk about later. And here's nuclear, a little ribbon there, and a little ribbon of hydropower. Renewables don't really even show up yet. They're about 10% of US energy, but maybe, a couple of percent of world energy use. So that's just barely starting. So a couple take-home points from this chart is energy transitions from coal to oil and oil to gas takes a long time, about 70 years if we do it organically, for lack of a better word. If we just let convenience and economy steer these energy transitions. But we have frontal lobes, we can think ahead, and we need to realize that this is causing all sorts of problems environmentally, equitably, socially, geopolitically, and that we should switch off of these sorts of things sooner than later and not just let it happen driven by pure real economics. We'll talk a lot more about that in the second half of the class. Yeah, so let's get into energy and society. So let's stop sharing this one, share the one I do want to talk about. Let's just jump straight into this. So can you all see a map of the world here? So this is, you may have seen this in other things. This is a map of the Earth at night. It's several pictures mosaicked together. You can't take a single picture of the Earth at night because the sun is always shining on half of it. But it's a couple things that are really, really interesting about this. I'll let you guys talk. What do you see?
Just the wealth of nations and the distribution of light.
Yeah, the distribution of light. What's lit up or what's not lit up?
You can see areas lit up where there are large concentrations of people.
Yeah, so let's go to, what we're familiar with. Here's Bellingham is right here. Here's Vancouver up here. I'm looking at a cast. North Korea is completely dark. Yeah, we'll look at that in a sec. Lights near the coast. So that's an interesting thing. In general, yeah, you see lights near the coast. Here's Florida. I like looking at the Spanish, French, and Italian Riviera. So you see this string of lights hugging the coast there. There's a geophysicist slash philosopher last century, William Dement, who said, society is subject to geological constraint. What does that mean? It means that societies are built where it's geologically conducive. You don't have societies on the Alps, you have it right on the ocean. I think there's no more clear indication than this than if you look at the Nile right here. So check this out. Like, you only have society on the Nile. You don't have it anywhere else. I mean, yeah, there's Siwa here, a little oasis, but that's about it. Yeah, let's hop over to North Korea. So you can see the DMZ, the demilitarized zone, in this map of light at night. So this is the DMZ right here. It's lit up with a string of halogen lamps, and if anybody tries to go over there, they'll catch a bullet, right? There's Pyongyang. Here's Seoul. Cities have similar populations, but very, very different energy use. So something crazy happened here. Unless this is just a conspiracy to make North Korea look bad, and this map isn't actually how it looks.
That's probably what it is.
It's probably what it is. So has something to do with wealth, right? Nation states with more money, higher GDP, consume more energy, and use that energy to deliver services like being able to see in the dark at night. Let's look at some other things here. Yeah, so here's Japan, tremendous amount of electricity consumption, very robust economy, but again, subject to geologic consent. All the cities are located in low-lying areas that are relatively flat, not in all the mountainous regions. So back over to America. On the West Coast, which I'm more familiar with, you can see LA, SF, Portland, Seattle, Vancouver, quite well. But it's not nearly as populated as the East Coast. So these are these megalopolises along the eastern seaboard, spanning from Boston down to Philly or whatever, or further. And so that's all happening here. But I think it's interesting is in the middle of the country. Look at what is up with these like spokes and these regularly spaced dots.
It looks like a grid.
Yeah, it looks like a grid. It looks like graph paper. What the hell? Let's go over to Europe. We don't have graph paper. Instead, we have these hubs and then like radial spokes. So here's London. It looks like, you know, stars with radial spokes. Here's Paris.
All of Europe looks like a constellation.
Yeah, it looks like a constellation. You have these little like nets, right? Rather than a grid. That's how cities were built pre-car. Yeah, that's exactly right. So the transportation technology, which is a direct result of the energy consumption and energy sources available to a society, shapes how that society is actually built. So this was built via shortest distance paths that horse and humans would travel between cities that were conducive for farming. Paris and London were big agricultural centers. You go to America, and aside from New York and Boston and a few other cities, as soon as you get west of Chicago, this was all developed post-automobile. And so all these cities are laid out along interstates and highways. And they're spaced fairly regularly as town centers for agriculture to acquire supplies. And so you have this grid shape, and it's all a relic of automobile use. I mean, the big cities are located, again, due to conducive geology, but then the distribution of smaller cities and the connections between these big cities, it's all just automobile. It's has something to do with that fourth law of thermo I was talking about the other day, something about maximum entropy production. So this is a way to distribute goods and consume energy gradients at a societal scale, now that there's this new carrier, the automobile. Something to there. I don't know. It's smarter than I am, but something curious. Let's look at some other things on this map. So we've been focusing on the northern hemisphere, which is, you know, very biased and not what you're supposed to be doing. And so let's look at the southern hemisphere. A lot less light at night. Seattle, about 1 million people. Let's go to another city with 1 million people. So let's look at Seattle really quick here. Sorry if I'm making you sick. Here's Seattle, 1 million people. Wow, that's zoomed out. Let's go to Antananarivo, 1 million people. Right here in Madagascar. So here's Antananarivo, 1.3 million people or so. Small bit of light there. Right next door, not right next door, but in the Indian Ocean is the, these are the Maldives, right? Or is this Mauritius? Or is Mauritius part of the Maldives? I forget. I'm pretty sure these are the Maldives, and they're completely lit up despite having far, far lower populations. But this is a French honeymoon destination. So this is where wealth is contributing to energy use. United Arab Emirates. Oh yeah, that's fun to look at. Thank you for reminding me of that. Okay. So here is the Strait of Hormuz. This is the most geopolitical sensitive 11 miles in the entire world. Not to give you any ideas, but if you want to start some serious shit, close this down and you'll choke off oil to most of the entire world. So this is an incredible location right here. And so here's United Arab Emirates. This is Dubai right here, and Abu Dhabi down here. Incredibly wealthy. And what are these glowing orange balls? What's that?
Boats.
Tankers, oil tankers? Close. Oil
Oil
rigs.
drills?
Yeah, these are not drilling platforms, but production platforms. So these massive, massive platforms, the biggest machines that humans have ever built that can simultaneously siphon from like 16 production wells. And they're producing a tremendous amount of oil, but floating on top of oil is natural gas. And if it's not economically conducive to ship that natural gas somewhere, and usually it isn't when you're in the middle of a sea like this, you light it on fire. And so these are massive natural gas flares from oil production rigs. Here's Qatar here. Yeah, so all this orange stuff is gas flaring. Gas flaring all over the place. Yeah, and you can see that, and should be able to see it. Yeah, across Siberia too. There's a flare right there, and oh, I forgot it's not a circle, it's a square. I was thinking globally rather than Mercator projection. So I have to go all the way to the other side to get to Alaska. And here we have flares too, up in, sorry if you're from Alaska. How do you say that? Prudhoe Bay? Prudhoe Bay?
Prudhoe Bay.
Prudhoe Bay, yeah. So here's where some other flares are happening. And again, it doesn't make economical sense to ship natural gas from these locations. And so you flare it because it's not safe to just have laying around. Any other places we want to look at on this map before we jump into lecture? I think I hit most of the highlights. I think the last thing I'll talk about is that look at Baker, North Dakota for flares. Yeah, I will in a sec. Here's Nigeria. There's a bunch of flares here, and then in the Nigerian Delta, where we used to get 20% of our oil from there back in the 2000s. So yeah, here's massive rainforest here in Central Africa, and here's the Sahara. The rainforest is dark because it absorbs light. The Sahara is bright because it reflects light. And so there's something called albedo, and that's the reflectance of the surface of a planet in any location. And it goes from 0 to 1, 0 being purely absorptive, like a piece of dark carbon, and white being a mirror, or 1 being a pure white, or like a mirror. And so what's scary is as desertification happens, this will get higher and higher albedo. And as the caps melt, this will get lower and lower albedo and absorb more radiation and cause a feedback loop that could cause more melting. Okay, Australia seems weirdly dark. Yeah, Australia is pretty inhabitable in most of it. So it's really you just have population centers on the coast. And then finally North Dakota. Where is it? This is Wisconsin, so it must be kind of over here somewhere. That might be some flaring up in Canada. Yeah, I don't know. Maybe this map is too
Upper
old to
left corner.
capture some of this. Yeah. Yeah, so have a look at this. There's even a higher resolution version of this that's even more interesting to look at, but I didn't want to bog down my computer in the middle of the lecture. But it's pretty amazing to think about and understand where these lights actually come from. So let's dive into the why. Share screen. Get my chat back open. I don't know why my chat always closes whenever I change my screen. Okay. Oh yeah, interesting comment on Brisbane. 2x seems less than 3x the size. Huh. Yeah, I'll have to think about that. Okay. Challenges for humankind in the 21st century. You all are Gen Z or Gen Alpha. You have to figure this out. What are some challenges facing us? What are the things you hear about Rosie raised her hand. What do you think? Climate change? Yes,
Yeah,
definitely.
I was gonna say climate change.
Yeah, that's a big one. Capitalism. Yeah, the cause and solution to all of our problems. Second, capitalism. Yeah, it's going to be difficult to solve the infinite growth mindset with a system that's built for infinite growth, or use use the economic system that caused all these problems to solve the problem. The only way we'll do that is if we actually accurately price things, these so-called externalities, things that are not priced accurately. One of the biggest ones being carbon dioxide. Right now, we can throw carbon dioxide into the atmosphere for free. It's tantamount to throwing our feces in the street, and normally we wouldn't be allowed to do that. We have to pay for someone to take that away, and right now we're not paying for the carbon we emit. Water scarcity, socialism and communism, they're problems too. Yeah, communism's kind of like nuclear energy. It's a fantastic idea until you get people involved. Extinction of animals, water scarcity, yeah, that's a huge one. The water, energy, food, hate triangle is definitely going to be a scary thing. What are we dealing with right now? You're like, how?
Denial.
Let me count the let me count the ways. Yeah, pandemics. Yep. So as the world becomes more connected, we're going to have more and more pandemics, and that's a direct aspect of our energy use. Yeah, democratic socialism works in some nation states. The Scandinavian nations and New Zealand are good examples of democratic socialism. Decreasing fossil fuel supply, yeah, harder to get oil, scraping the bottom of the barrel, literally. Yeah, geopolitical instability. You guys have hit them all. So fresh water is a huge issue. South Africa was running out of fresh water the last couple of years. So actually a lot of the oil majors are working on desalination plants and pipes and pumping to get water to South Africa. Hunger, so as population growth continues to grow, we don't have a food production problem, we have a food distribution problem. Anybody know how much food we throw away in America? It's a fraction of our food production.
Half, right?
Half, yeah. It's terrible. We want our produce to look really pretty and arranged in orderly fashion at Whole Foods Market. Poverty, so enough resources to live healthy, happy, productive lives. Disease, so we're dealing with COVID-19 right now, but there's other ones too, and there's more on the way. As we destabilize the permafrost, we'll release diseases from the early Holocene that we haven't seen for 10,000 years. Speaking of food waste, somebody threw a burger in the middle of the road yesterday. Yeah, we have too much food here. At least hopefully a raccoon got it or something. War, so war will be over land, probably due to things like water and energy resources. Most of the wars in the last 30 years have been over oil. Don't get it twisted. But now with fracking, we don't have to fight wars over oil anymore. For a little while anyways. Water, religion's still a thing that causes people to fight. So it's the 4 horsemen, right, of the apocalypse that we'll have to deal with. I contend that energy is related to all of these things. Energy is required for complex societies. It's this limiting agent for a lot of things. If you have enough energy, you can produce a lot of these other items. If you have enough energy, you can desalinate water and make fresh water from salt water. If you have enough energy, you can grow food. When you buy a tomato here in Bellingham in February, do you ever look at where it's actually grown? Do you see the origin of location? It has a cool name. It's called hothouse tomato. What's a hothouse? Greenhouse, yeah. So if you're not allowed to right now. A hothouse is hot. Very good. You're not allowed to cross the border right now, but if you go up to Vancouver in the before time, you'd see all these greenhouses for the 30 miles between the border and Vancouver City proper. And so they're growing a ton of plants, for lack of a better word. Some of them are smelly. You can smell them from the freeway. And but they also are growing things like tomatoes that we can buy at our markets here in February. And so, yeah, if you have enough energy, you can grow food. If you have enough energy, you can desalinate water. If you have enough energy, you can fight disease. That's why the Bill and Melinda Gates Foundation, for example, is very interested in energy, because with energy, you can refrigerate medicines and blood and plasma and vaccines and distribute them widely across sub-Saharan Africa, for example. If you have enough energy, then hopefully you don't need to fight war over things like oil and gas. The Caspian Sea is going to be a very interesting thing to watch the next couple of decades. A lot of oil and gas is available there. Russia already took over Crimea in the last couple of years, and so access to the Caspian Sea is going to be interesting. Yep. So I think energy is this limiting agent that can alleviate a lot of these problems if we use it smartly. So energy is the lifeblood of modern society and civilization. Some people say money makes the world go round. Money is just a marker for power and choice and change. What actually causes power and choice and change is the consumption and use of energy. So when I give this talk to different audiences, I usually just do 2 of these different elements, but you're a well-rounded, well-educated audience. You're capable of critical thought, and so you can handle all 3. If I'm talking to Republicans, I just talk about economy and society. If I'm talking to Democrats, I just talk about society and environment, but let's talk about all 3. And this isn't a defense of enlightened centrism. I'm very much a progressive, but progressives need to be aware of the economy as well. So to have a stable, functioning society, you need to have secure energy so that it's predictable, and this allows economies to grow when the factories know that they're going to get energy every day. And it needs to be resilient and profitable, or people aren't going to invest in it. Protective is the next spoke here. And so we have to have energy systems that don't destroy the planet, don't destroy the local environment or the global environment. And so it needs to not give people asthma or cancer or make them sick. It needs to not destroy the global climate. It needs to not pollute our water and not destroy habitats. And then finally, energy needs to be accessible. So it needs to be equitable, so all of us can benefit from energy use. And to be equitable, it needs to be either affordable or widely distributed. It needs to be abundant. Again, it needs to be reliable and useful and efficient. So these are the 3 things that functioning society needs, and they're all dependent on secure, protective, and accessible energy. Energy use is pervasive in modern societies. That should be self-evident by now, just by learning about your own personal energy use. It's strongly correlated with economic activity. You can trace it to empires, right? England was the empire in which the sun never set back in the 1800s, and it's because they had this huge wealth of coal. Their entire empire was driven by coal. Today, America, maybe not for long, is the prevailing hegemony, and we're an oil-based empire. Post-World War II, we had access to a tremendous amount of extremely cheap oil, and with that, we were able to build the greatest military that humankind's ever seen. And with that, we were able to project power across the entire globe, and we still do so. So energy use is, strongly correlated with empire, societies, economic activity, etc. And our global energy use will continue to grow as we economically develop and as population grows. Here are 2 different locations in the world. which one might have more energy use? The population looks about the same, but the wealth looks different. So yeah, any idea where these places are? India, yes. Where in India?
This side doesn't look like it's from in the US because they're driving. Are they driving opposite?
Yes, they are driving opposite. Yeah,
Bangladesh.
Mumbai. Which one's Mumbai?
Right side?
I think the one on the left, it looks like, I don't know.
Yeah. Yeah, it's a trick question. They're both Mumbai. This is Davari, a slum, one of the biggest slums in Asia, in northern Mumbai, and this is southern Mumbai, which is very posh. So this is the same city with very, very different energy use occurring in the exact same city. I just think it's fascinating. Okay. So we've already covered all this, so just shout it out. World energy use depends on what? Two main components.
Accessibility.
Yes, accessibility.
Wealth
Yeah, wealth
and population.
and population. That's it. So the more people you have in general, the more energy you're going to use, and the more wealthy you are, the more energy you're going to use. The more wealthy a society is, the more energy they're going to use. The crazy thing about energy is we don't get satisfied with it. What's the word? Our energy use is insatiable, right? You eat a piece of chocolate, it tastes good. You eat 2 pieces, it tastes pretty good. You eat 3 pieces, you're like, no more. You eat 4 pieces, you start getting sick. We quickly satiate on things we eat, right? But energy is this bizarre thing where there's no limit. The more access you have to energy in general, the more energy people use. And so you look at the most wealthy people in the world, and they're building freaking rocket ships, right? And that's the most energy intensive technology we've come up with. And yeah, so in general, the more wealthy people are, the more they consume, the more cars they have, the more air travel they participate in. They buy yachts, they do all sorts of things. So wealth is directly tied to energy use, and you can break that cycle. We'll talk about that towards the very end of the class. But in general, it's a difficult truth that yeah, the more wealthy you are, the more energy you're going to consume. But let's not feel too bad for them, right? So how do we measure wealth at a societal scale? What was the third again? Something like access to energy, which is a marker of societal wealth, right? Generally, more wealthier societies have more access to things like electricity. I'll show a graph on that in a sec. Okay, I'm gonna start cruising to get through some of these interesting things. So we measure society's wealth by their gross domestic product. It's a measure of all economic activity and exchanges undergone by a particular nation. It's a little bizarre because, like, if I get paid $5 to mow my neighbor's lawn, and I pay them $5 to have them mow my lawn, then you know, the net is we've made zero money, but we both got our lawns mowed. But GDP would measure $10 of economic activity. But in general, it's a good way to measure societal wealth. So it's the monetary value of all finished goods and services produced within a country's borders in a specific time period. Usually we do it annually, annual gross domestic product. And using that, we can estimate pretty accurately society's energy use. And so there's this member, a scientist and economist of the IPCC, the Intergovernmental Panel for Climate Change, during the 1997 meeting, this individual, Yoichi Kaya, came up with this pretty simple formula. It's stupidly easy. And sometimes, you know, the simplest things are actually really smart and useful. It's just a tautology. It just says energy equals energy. So if you look at the units, population cancels and GDP cancels. But if you know these individual numbers, these three numbers, you can get a very close idea to your energy use, a household's energy use, a city's energy use, or a society's energy use, or global energy use. So you say how many people live in a particular country, you plug that in for population. You say how wealthy are those people, so you take the entire GDP of a nation and divide it by the number of people. The per capita, that's what that means, per population, per capita GDP of America is about $50,000, $55,000. That means, you know, on average, every person in America generates about $55,000 of economic activity in a given year. And then this final number is tricky. It's called energy intensity, and it says how much energy does it take to make money? How many joules does it take to make $1, right? So I can, if I mowed my neighbor's lawn for $5, I'd use like a cup of gasoline. It'd have some energy equivalent, and I could divide that by that $5, and I could calculate the energy intensity, the monetary energy intensity of that activity there. Something like mining for iron or gold or something is very iron, let's say iron because gold's valuable, is very energy intensive. It takes a lot of energy to generate money that way. Something like banking is very energy unintensive. Wow, I'm not contributing to GDP at all. You actually are by paying for a university education, right? You're not recouping wealth, but wealth is definitely spewing out of you into society. And so you are contributing to GDP. So yeah, if you look at any nation state, and this is what I want you to do with the EIA and CIA, is look at their population, look at their GDP, and look at their energy and try to, you know, calculate their energy intensity. How much energy does it take for different nations to generate wealth? A place like Ireland, not a lot. A place like Russia, quite a bit. We'll talk more about it later. So these are basically the levers we have to think about how much energy we'll use as a globe. We can control population. Generally, that's a bad idea, right? You know, people have tried to do that in the last century. It was a bad look. We can do it in other ways. Women's education is the most important thing we can do for limiting population growth. Turns out if women are allowed to go to school and allowed to participate in and have control of their own, you know, decisions and livelihoods as an adult, one decision they make is, I don't want to have 12 kids. And that helps limit population growth, and it leads to happier, healthier societies. GDP per population, this again requires steady flows of energy to create steady societies. And so promoting democracy, promoting, again, women's education helps with that element too. And then energy intensity, this is a tricky thing. Societies need to move from resource extraction-based societies, which are very energy intensive, to more, service-based societies. All right, I won't talk about population rates. Basically, population rates have fallen tremendously in developed nations and not so much in less developed nations. This is directly tied to women's education. Let's skip all that. This is wealth and its relation to energy accessibility, but I only have 5 minutes, so I want to spend some time on this chart. This is a thing of beauty. It's dated. The last entry was in 2010. It was from this doomer blog called the oildrum.com, where they were obsessed with peak oil, this idea that we'll run out of oil, which was true to a certain extent. We ran out of conventionally produced oil, the easy to get to oil, but now we moved on to liquids, things like tar sands and stuff like that. But anyways, the x-axis is GDP per capita. So this is total nation's wealth divided by its population. And the y-axis is primary energy per capita. So how much energy each person uses over the course of the year. So it's energy versus money. Those are the axes. And then each dot along one of these things, let's do America. USA is red up here. Each dot is a different year. So here's 1980, 81, 82, 83, all the way to 2010. 2010, 2009, 2008, what happened here? Why did we all of a sudden have less money, less energy?
Because of the economic crisis that happened during that era.
Absolutely right. So there was an economic crisis, and our energy use and money use, again, money's kind of a marker for energy, went down drastically. So America did an interesting thing over those 30 years or so. Our wealth drastically increased, but our energy consumption didn't go up that much. What happened? There was some efficiency gains, but primarily we were transitioning from a extraction-based economy to a service-based economy. We were producing good American steel and oil and all these sorts of things, and now we produce economic services. We've moved to biotech, information technology, just financial services, that sort of thing. Let's look at what's this one? South Korea. So from 1980, they went from a developing nation to a fully developed nation, and their energy use and wealth grew in tandem. A lot of nations followed this path. This is Mexico here. Where is China? China's down here. It's probably up to about here now. Even though their GDP has now surpassed ours, their GDP per capita, because they have billions of people, is still quite low. But there are parts of China that are incredibly developed, much more so than we are, arguably. Here's a sad story, Russia. So the collapse of communism was happening throughout the 80s, and then completely collapsed, fall of USSR and the development of Russia, and now they're climbing out of that hole in the last 20 years or so. Ireland, much lower energy use than America, but similar levels of wealth per capita. Why? Ireland is an entirely basically a service-based economy. They don't make things like steel or oil. What they do is they are how do I say this in a nice way? I love Ireland. They're like a money laundering service, right? They take British pounds, US dollars, and euros and trade them back and forth and skim a little off the top the entire time. Yeah, and they make whiskey, yes. So they're able to generate a lot of wealth without using a lot of money without using a lot of energy, because money is an abstraction, right? It's just an idea. And yeah, that's what's happening there. All right, I think I've killed this. If anybody's interested in helping, extend this to 2020, let me know. We can think about, independent study credits if you're interested in pursuing a degree in energy sciences or energy policy. This could get you a few credits if you help me build this out over the course of a quarter. I think it'd be really interesting. All right, 2 minutes left. Energy is the lifeblood of society. This chart shows electricity access as a fraction of percent of population from 0 to 100% versus percentage of population below $2 a day. So OECD is Organization of Economic Countries Developed. It should be like developed countries, but it's based in France, so they changed the noun and the adjective around like they do in Spanish. So this is all the countries that are very developed. So the United States, France, Germany, etc., China, all fall into there. Not China, but yeah, a lot of Western superpowers fall into the OECD, and they're all right at 100% access. That's not totally true. There's still such thing as the global South, and there are places in America. Probably if you go up Baker Highway, you're going to find places where people don't have access to electricity. But in general, 99.9% of Americans all have access to electricity. But if you start going to a place like Madagascar, we looked at Antananarivo on that map, and here 83% of the population lives off less than $2 a day, and only 10% of the population has access to electricity. Where's Kenya? Yeah, Kenya, very poor access to electricity, largely dependent on fickle hydropower that's dependent on monsoon seasons. 62% of the population living below $2 a day. My wife was working at an AIDS clinic in Kisumu, and I was tagging along, and I was just writing a research paper, and I'd spend my days walking around Kisumu trying to listen for a generator, because if there's a generator going, then I knew I could go into that cafe or hotel, order a cup of tea, and then plug in my laptop and get to work. But yeah, electricity was very, very fickle there. And so you can see this direct relationship between energy access and wealth on this chart here. Hans Rosling was this amazing statistician. He died a few years back, but his Gapminder software is still freely accessible, and it has a bunch of databases that you can plot against each other. So I did a few things here with energy on the x-axis. This first one is new cases of tuberculosis, so disease as a function of energy use per person. The less access you have to energy, the more likely that you will be susceptible to disease. There's a few crazy outliers here, mainly due to religious pilgrimages, not to knock them at all, but for example, the Hajj, where a bunch of Muslims come together to practice their religion. It's a good vector for disease as well. So that's why there are some outliers here. You could probably say the same thing about a Trump rally, right? Here we have energy use per person, again on the x-axis, and maternal mortality. So this is the likelihood that a woman will die during childbirth is directly, again, related to the accessibility to energy use. So energy access is critically important for healthy, happy, growing populations, and human index. Energy use is projected to go up in the next half century due to population growth and wealth, primarily due to wealth in developing nations. So a lot of developing nations are becoming wealthier, which is a great thing. It's improving quality of life, and but our energy use is going to rapidly grow with the development of primarily sub-Saharan Africa in this next century. India and China are well on their way to development. So that's shown in that chart here with India and China, and then I think that's about it. Basically, we're going to double our energy production and consumption over the next 50 years in this planet. So we have to do so without completely trashing the place. And the only way we'll do that is switching from big stores of fossil fuel, oil, coal, and gas to real-time flows of renewable energy, wind, solar, and hydro. And so that's the task we have in front of us, and that's what we'll spend most of the rest of the class discussing, how to solve this huge problem. And hopefully it takes a lot less than 70 years like the previous energy transitions from wood to coal, coal to oil, oil to gas. All right, questions?
Thank you, sir.
Yeah. All right, we'll talk a lot more about all this Friday, and I'll share a little more information about the midterm Friday once I have it written.
When are you sharing the film?
What?
Sorry, I was asking, when are you sharing the film for us to watch?
Yeah, so there'll be a paragraph question about that film on the midterm. I think I mentioned that in the announcement. And I linked to it directly in the announcement on camp. Oh, sorry, I'm still sharing my PowerPoint. Forget how you don't always see what I'm seeing. This screen. Okay, so here's the Canvas page. So if you click announcements, there's a link to it here. It's on Vimeo. So short film on Mauritania. You can also get to it in the societal energy use module, idea 3. So it's down here, Mauritania Railway. So if you click that, then click open Mauritania Railway in a new browser, it'll be available there.
I have a question.
Yeah.
On the midterm, are you going to have some quantitative questions like?
Yeah, I'll have something on the heat capacity equation. Think about heating a hot water tank or something like that for taking showers. And then tied with that question, I'll have an efficiency question. So you make this much hot water, burning natural gas, for example, how much energy did you actually burn in the natural gas? Something along those lines. So you have like efficiency equals, the energy in the hot water divided by the energy in the natural gas. And I might have, think about how long it takes to heat up that hot water tank. And so then you'd have to use the power equals energy over time equation. You'd rearrange it for time equals energy divided by power. Nothing you haven't seen before in the homework. The only new stuff will be the society energy material. But again, we can talk about it all 3 days, Monday, Wednesday, Friday. Mainly Monday, Wednesday, because I think it'll be due Friday. Yeah. Again, this is a one-on-one class. I just want people to learn some good stuff, not here to fail anybody. And I want to make it so everybody can get an A if they put in the effort.
So you should just use homework and lectures to study?
Yep. That heat capacity chapter in McKay would be very useful.
Thank you.
Yep.
I think I might know what's going on with you not being able to see chat when you're sharing your screen.
Yeah, help me out.
Whenever you go to that the first time, I know mine defaults to full screen. And then if I just go up to the upper right-hand portion and toggle that back the other way, if I have chat selected, it'll just pin that to the right-hand side and I'll still be able to see the screen share and everything else at the same time.
Okay, so how do I toggle the full screen versus not full screen? Oh,
It should be right next to speaker view versus gallery, that icon in the upper right of your blacked out background.
I see mute, stop video, security, participants, polls, new share, pause share, annotate.
Let's see, at least for the layout, yeah, that's down at the bottom. Up at the top, above the gallery of videos, speaker view and all that, versus gallery view. Do you have that same?
No, unfortunately I don't. And the
Maybe it's different for host.
We're on the top of mine.
Okay, so I guess it's laid out differently.
Yeah.
But there should be something for full screen or not. And when you pop it out of full screen, it allows you to have the chat open at the same time.
Okay. Yeah.
Usually, I don't know about you, Aaron, but when I screen share, it takes up the whole screen because the screen is the thing being shared.
Oh, okay, so it might be different from hosting versus
okay, now I see
viewing.
speaker view.
Yeah, it's different if you're hosting versus if you're watching one, which is interesting.
Well, I've figured out if I just press if I just press like Alt H, the chat reappears. So that's what I've been doing lately. It makes an annoying chime, but so far it's gone pretty well, I think. I should probably do more breakout rooms, huh?
Depends on how they're executed, how effective they can be.
Yeah. But please continue to help me if you have ideas or criticism or anything. Let me know. This is the first time I'm doing this style, and feel like I'm building the plane as I fly it.
Yeah, it seems to be something that most of my instructors are having issues with, is things like trying to view the chats and figure that out. But you've so far got the best handle on it I've seen.
Okay, I appreciate that.
I did want to ask, what's your camera setup? You've got really good quality on your end.
My main camera is a Fujifilm X-T3 mirrorless APS-C sensor with a, I think the lens is what's good. I have a 16 millimeter lens at an aperture of 1.4, so it's really.
Okay, so you're streaming through an actual camera.
Yeah, it really lets in a lot of light. And then my document camera is actually an even better camera. I just like the color science of Fuji better. My document camera is a Nikon Z6 with a 2470 f4.
Okay, I wouldn't have even thought of that, to hook up the mirrorless to the computer for streaming.
All right, let me actually share the. Yeah, so you can see the Nikon there.
Yeah.
And then, yeah, if I switch to the Nikon, yeah, there's my Fuji there.
And it really seems to help with lighting too, because it captures lighting very well.
Yeah, it's just, that's way bigger. So many more photons are going to go in there than a teeny dot on your laptop.
Huh.
Yeah. Yeah, you just plug the HDMI out into your computer or into a USB card. It should work.
I'll have to play around with that. Thanks.
Yeah. Cool. And again, thank you for your help and your participation. It makes the lecture much more interesting.
Dad, could Grandma do spelling for me?
Sorry, my daughter needs some help with school now. I'm gonna go.
Just
See you next class.
Bye.